everyone, I'm Tuba, your maths educator on study. So before starting the video, I would like to say, don't let the numbers bother you because mathematics is all about playing with numbers. So in today's video, we will discuss a topic that is algebraic expressions and identities. So this is a chapter of mathematics where we will observe the mixing of the English alphabets along with the numbers. I hope you all must be excited. So let's get started. The very first thing that we will discuss is expressions. Expressions comprises of three things: variables, constants and mathematical operators. Variables means whose value keeps varying and is represented by letters of the English alphabet that can be any letter X, Y, Z, A, B, C. Second is constant, means whose value remains fixed. It can be represented by any integer -1, -2, 0, 1, 2, 3 and so on. And the third thing is mathematical operator, which is addition, subtraction, multiplication and division. So let us take an example of an expression, that is 2x minus 5. So here 2 is a constant number which is multiplied by a variable y and then it is subtracted by a constant number, that is 5. So this is an example of an expression which comprises of three things: variables, constants and mathematical operators. Now let us solve this expression by putting different values of the variable y. The first thing we'll do is we'll put the value of y is equal to 2 in the given expression. So when we put the value of y is equal to 2, we get 2 multiplied by 2 minus of 5. We know that 2 into 2 is 4 minus of 5, which ultimately gives us minus of 1. Now we will be putting a different value of the variable y and see what is the value of the expression. So let us put y is equal to 0. When we put y is equal to 0, the value of the expression turns out to be 2 multiplied by 0 minus of 5. 2 multiplied by 0 is 0 minus of 5, which ultimately gives us minus of 5. Now I will teach you how to represent an expression on a number line. So to do so, let us take an example. The example given over here is x plus 5. The first step to represent an expression on a number line is to take an initial point. So we have taken an initial point O. From O, we will take another point, that is capital X, such that this distance from O to X represents the given variable, that is small x. Now we have to represent plus 5 as well. So for doing so, we will take another point P, which is at a distance of 5 units. And remember one thing, it should be towards the right of x because here we are adding plus 5. So this point P ultimately represents the given expression, that is x plus 5. So from here we can conclude that this capital X can be represented anywhere on the number line, but this point P, which represents the given expression x plus 5, should be towards the right of capital X at a distance of 5 units. Now, what about the position of 4x and 4x plus 5? How to represent it on a number line? Let us learn. So, we will draw again a number line. Take an initial point O. From O, we will take another point capital X such that this distance from O to X represents small x. Now, let me tell you one thing. This 4x can be written as x plus x plus x plus of x. So, when we took this point capital X, so this point represents x. But we have to take 3 more x's. So, we will take 3 more points A, B and C towards the right of x, such that this distance from x to A represents the variable small x. Again, the distance from A to B is also small x and the distance from B to C is also small x. Now, so this point C represents the given expression, that is 4 times of x. Now, we have to represent another expression, that is 4x plus 5. So, we can say 4x plus 5 can also be written as, like we have here 4x plus of 5. This can also be written as x plus x plus x plus of x, and again we will add a 5 here. So now to represent this expression we have already represented 4x, like this point C represents 4x. Now in this 4x, we need to add 5 units. In adding 5 units, what we have to do is, we have to take another point B towards the right of point C at a distance of 5 units from it. So we can say that this point B represents the given expression 4x plus of 5. I hope everything's clear. Now we will discuss some more examples to make our concept even better. So we will represent the very first equation. Okay, the expression given over here is x. We have to represent this on a number line. So we will first draw a straight line. Then we will take an initial point, that is O. We will take another point, that is capital X, such that this distance from O to X represents the variable small x. So we can say that this point capital X represents the given expression, that is x. The second question that we have over here is x minus of 4. To represent this equation, we have to draw a number line and then take an initial point, that is O. From O, we will take another point, that is capital X, such that this distance from O to X should be small x. Now, we have to represent x minus 4. In the previous questions, when I have to represent x plus 5, so we took another point towards the right of x. But here, this constant term 4 is subtracting from x. So what we have to do is, we have to take a point towards the left of x. Let's say we are taking a point A, which is at the left of x. And this distance should be 4 units. So we can say that this OA is x minus of 4. So ultimately this point A represents the given expression, that is x minus of 4. The third example that we'll discuss over here is 2 times of x plus of 1. To represent this expression on a number line, the very first step is to draw a straight line. We will take an initial point O and we will take another point capital X, such that this distance from O to X is small x. Now we have to represent 2x. That means we will take another point A, which is at a distance of x units from this capital X. And we have to represent plus 1. For this, we will take another point B, such that this distance from A to B is 1 unit. So we can say that this very point B represents the given expression, that is 2x plus of 1. Now let us take another example. So the example number 4 we have is 3 times of x minus of 2. So this can also be written as x plus of x plus of x minus of 2. Let us represent it on a number line. We'll draw a number line, take an initial point O, then take another point capital X, such that this distance from O to X is small x. We will take another point A towards the right of capital X, such that this XA distance is small x, and then take another point B, such that this distance AB is also small x. So we can say that this point O till B represents 3x. But now we have to represent 3x minus 2. I told you whenever a constant is subtracted, then we have to locate a point towards the left hand side. So we will take another point C, which is towards the left of B, and it is at a distance of 2 units. So this point C will ultimately represent the given expression, that is 3x minus of 2. Now we will talk about terms. Terms are the individual building blocks of an expression. They add up to form an expression. So let us take an example. So the example given over here is 4x plus 5. This is an expression. So from here we can see that we have 2 terms. One is 4x and another term is 5. And they have been joined by a mathematical operator. Now, when we take a term that is 4x, let us know the factors of 4x. We have 2 factors of 4x, that is 4 and x. And when we multiply these 2 factors, we get this term. So from here we can conclude that a term is the product of its factors. Whenever we multiply the product of the term, then we get whenever we multiply the product of the factor, then we get the term. So these two terms together comprises of the expression. Now that we have learned about terms, we will talk about factors. So factors are those variables or constant whose product makes a term of an expression. Let us understand this better with the help of an example. So the example that we have over here is 4 times of x. So this is a term of an expression. So the factor of this term is, one is 4, another is x. 4 is a constant term and x is a variable. So the product of this 4 and x gives us the term of an expression. So 4 and x are the factors of the given term of an expression. So let us take another example, that is 7xy minus of 5x. This is an expression which has two terms. The first term is 7xy and the second term is minus of 5x. So over here in the first term, what should be the factors of this term? The factors of this term should be 7, x and y, because when we take the product of these three factors, we get this term 7xy. Again, we have another term that is minus of 5x. So what are the factors of minus 5x? It is minus 5 and x. So when we take the product of these two factors, that is minus 5 and x, we get minus 5x, which is a term of an expression. So factors are those constants or variables whose product gives us the term of an expression. Now we will take another example where we have to find out the terms and the factors of an expression. The expression given over here is minus ab plus 2b square minus of 3b square. So as you all can see that this is an expression comprising of three terms. The first term is minus ab, second term is 2b square and the third term is minus of 3b square. Now let us find out the factors of each of the terms. So the first term we have over here is minus of ab. So from here we can clearly figure out that the factors are minus 1, a and b. Why? Because when we multiply these three factors, we get this term. Minus 1 into a into b gives us minus of ab. The second term that we have is 2b square. So the factors should be 2 into b into b. That is 2 times b square. So why we are taking b into b? Because b multiplied by b gives us b square. So the factors of 2b square will be 2, b and b. Again we have another term that is minus 3b square. So the factor of this particular term will be minus 1, 3, b and b. Why? Because when we multiply these four things, we get this term minus 3b square. The numerical factor of a term is called the numerical coefficient or simply coefficients. So here we are learning about coefficients. So if we have been given a term and we have been told to calculate the coefficient, how we will do it? So in simple word, let me explain you. When we have a term 7x, just observe the number that is before the variable. Here the number before the variable is 7. So 7 will be the coefficient of this given term 7x. Again we have another example that is minus of 5x. So the number that is before the variable is minus 5. So minus 5 is the coefficient of this given term minus 5x. So from here we can conclude that coefficient is nothing but the numerical factor of any term. Let us now try a problem to find out the coefficient of the terms of a given expression. So here we have to identify the coefficient of each term in the given expression. The very first step is to identify the terms and then identify the coefficient. So here in this expression, the terms are x square, y square. It is the first term. The second term we have is minus of 10 x square y. The third term we have is 5 times x y square. And the fourth term is minus of 20. So here we have so many terms. So we have to calculate the coefficient of each of the terms. So over here we find that this is a variable and the number before the variable is 1. Because we have nothing over here, that means 1 is multiplied to this entire variable. So the coefficient of this term will be 1, because I told you coefficient means the numerical factor before the variable. Now let us come to this term. Here the variable is x square y and the numerical factor is minus of 10. So the coefficient of this term will be minus 10. Again we have another term, that is 5xy square. Here the numerical factor before the variable is 5. So the coefficient of this term will be 5. And here this particular term is a constant term. So here we have minus 20 as the coefficient. Basically it's a constant term, or we can call it simply as a coefficient.